everyone. I am Mccaw.
I'm Herminian.
And today...
Dr. Quantum, by the way.
This is Dr. Quantum. Do not play with radioactive particles.
Well, today, the quick explanation. I have forced Ella to care about the wave-particle duality at a quantum level, meaning microscopic level. Is matter a wave? Is matter a particle? And this is what the experiment is about. And can you explain what the experiment
today,
is?
I'm going to be explaining the double slit experiment.
Correct.
And so basically what the double slit experiment is when you have like a sheet of like metal or something, and you shoot electrons with an electron gun at it.
And they have to go through
and
those
they go
two
through
slits.
the slits.
And what is it what we expect to see? This is
We're
our expectation.
expecting to see something like this.
And if you're wondering why, well, those are the two slits, and that's where the electrons went through. But what do we actually get?
We actually get this.
By the way, this is called an interference pattern, and this is what you expect to see if you were actually shooting waves through the two slits. And again, we're not shooting waves.
See, like
what
when I
we're
look at
shooting
these,
is electrons.
When I look at these,
there you go.
I see the waves. And when I look at these, like there's like wave patterns. And probably wondering, why is there wave-like property in matter? Well, that's a good question, because I'm going to answer that for you today.
Yes, and actually before she answers this, I want to actually say that when the experiment, again, this is what we expect, this is what we get. But, and this is the problem with the quantum level, if we decide to actually see what the particle is doing, and let's say that I put a detector here to measure if it's going through that slit or the other slit, what actually happens now is that we actually get what we expected. We get this pattern. Now, when we don't measure where the electron is going,
we get this pattern.
We get this pattern once again. So again, we do have a problem. Why is the same particle behaving like a wave and actually a particle?
This is one of the coolest science experiments known to man, because this man named Louis de Broglie,
French scientist.
And he was basically like, why does this happen? And he found out that all matter does have wave properties. You have wave properties, I have wave properties, Dr. Quantum even has wave properties. And we're like a wave. And this is really cool and mind-blowing, because like,
so technically
the
speaking,
atoms
we should be moving
are
like all over
going
the
into
place.
something else, which is really cool.
But the problem is we have so much mass that you cannot see our frequency.
Yeah.
The smaller you get, well, the more frequency you get. The other thing that we read when discovering this is that at that kind of microscopic level, you really cannot determine where these electrons or these photons or these particles are. You can only estimate or have a probability of where they're going to be, okay? But when you actually measure where the photon or the electron is going, you then determine exactly what path is going to follow, and that's why you get the expected pattern. Now, when you don't measure it, again, the probability takes over, and you get the interference pattern.
Science rules.
I agree. Well, thank you.
Mccaw out.
Bye-bye.
Shoutout Jane, scroggs.